happy to welcome you all to the course U21CH404 Process Heat Transfer. So I'll be handling this entire course on process heat transfer. So myself, Dharani, Assistant Professor Grade 1 at the Department of Chemical Engineering, KPR. So first let us look into the course objectives. This particular course named Process Heat Transfer has three main objectives. So the first one is to understand the fundamental concepts of heat transfer such as conduction, convection and radiation. The second one is to understand and apply the concepts of boiling, condensation and radiative heat transfer. And the third one is to develop a sound knowledge on different types of heat transfer equipments like shell and tube heat exchanger, evaporators, condensers. So we have 5 units and each unit is connected to one of the course outcomes. The first outcome is to understand the fundamental concepts of heat transfer and steady state heat conduction in solids. The second course outcome is to explain the convective heat transfer and heat transfer coefficients for laminar and turbulent flows. So the first course outcome is related to conduction, whereas the second course outcome is related to convection. The third course outcome is to describe the heat transfer in boundary layer and heat transfer involving phase change. And the fourth course outcome is understand the radiative heat transfer including black body radiation and Kirchhoff's law. So the fourth course outcome is related to the third mode of heat transfer, that is radiation. And finally, the last outcome is to calculate and use heat transfer coefficients in designing heat exchanger equipments. So these are the 5 course outcomes. Now let us have a broad vision into our syllabus. So now let us look into the unit 1. In the unit 1 we are going to cover introduction and to heat transfer and conduction. So the importance of heat transfer in chemical engineering operations, modes of heat transfer, as I said before, conduction, convection and radiation, one-dimensional steady-state heat conduction through plain and composite walls, similarly cylinders and spheres, thermal conductivity measurement, effect of temperature on thermal conductivity, heat transfer in extended surfaces, and finally transient heat conduction. So these are the concepts we are going to deal with unit 1. Now let us get directly into our unit 1. Okay, now what is heat transfer? Heat transfer basically deals with the rate of heat transfer from one body to another body. Now, before starting with heat transfer, it is very important to understand the difference between heat and temperature. Okay, now what is temperature? Temperature is a measurement of kinetic energy of the particles, while temperature is a measurement of energy in general. Okay, then what is heat transfer? Heat transfer is a form of energy, right? Temperature is nothing but it is a measurement of kinetic energy of particles. But heat transfer, this heat itself is a form of energy. It gets transferred from one body to another body. So we can easily say that heat is always in motion. That is, heat always moves from one body to another body. Whereas temperature, it doesn't move and it cannot be transferred from one body to another body. So this is one of the major difference between heat and temperature. We will look into the further differentiation between heat and temperature in the next slide. So for now, so what is heat transfer? It deals with the study of rate. Rate means it is the speed at which the heat transfer from one place to another, mainly due to the existence of temperature difference. Here, the driving force for heat transfer to take place is temperature difference. It deals with the determination of the speed or the rate at which heat transfer takes place. Some examples of heat transfer operations include boiling, condensation, heating, cooling, phase change, drying, distillation, and almost all of the chemical reactions that involve production or manufacturing of chemicals, involve either evolution or absorption of heat. Okay, so now most of the times we think or we believe that heat transfer is only when the temperature is higher. We can also say that cooling is also a process of heat transfer. Now, let us have a broad thing about the difference between heat and temperature. So, by definition, energy transferred due to temperature difference is called as heat. But temperature is just a measurement of kinetic energy of the particles. So heat transfer is always an energy in transit, but temperature is a thermal state of a system. So the normal units used for heat transfer are joules, calories and British thermal units. And for temperature it is Celsius, Kelvin and degree Fahrenheit. So this heat actually depends on mass, specific heat and temperature change. So what does it mean when I say the heat depends on mass? Say I'm taking 1 kilogram of a substance and the same substance I'm taking half kilogram. So I'm having the same substance of two different weights. Here, the heat transfer rate definitely depends on mass of the substance. The substance with 1 kilogram will have a different heat transfer rate and the same substance with a different quantity of half kg will have different heat transfer rate. So, heat transfer normally depends on, that is, heat depends on mass, specific heat and temperature change. I think you all know about specific heat. Specific heat is the amount of heat required to rise the temperature of 1 kilogram of a substance by 1 degree Celsius. Whereas this temperature is independent of mass and depends only on particle energy, that is kinetic energy of the particles. Transfer. Heat transfer can be done by made use of conduction, convection and radiation, but we cannot transfer temperature. So here is a broad differentiation between heat and temperature. Okay. Now we come into one of the most important parts of heat transfer, that is the three modes of heat transfer. The first one is conduction, second one is convection and the third one is radiation. Now let us start with conduction. Hope you can all look into this image. There is a stove under the bottom and I'm having a vessel on the top of the stove. Let us imagine I'm adding some water into the vessel and I'm heating this vessel. What happens? Now, the bottom layer of the vessel, which is a solid, through this bottom layer, the heat gets transferred to the inner layer of the vessel. Now, under conduction, the heat transfer takes place from one part of the body to another part of the same body, or from one part of the body through a different body, but both the bodies should be in physical contact with each other. Now, imagine the vessel and the handle. When you heat the vessel, the handle also gets heated. Now here both are of the same body. Imagine I'm taking a spoon and keeping it inside the vessel. Spoon is a different body. The vessel is a different body. But both the bodies are now in contact. So under conduction, the heat gets transferred from the vessel body to the body of spoon. So this is called as conduction. Conduction normally happens only in solids. Here is an example for conduction. Look at the image. There is a heat source and a metal bar is being heated using this heat source. Okay, the heat source is being at a one end of the metal bar. So the temperature of the metal bar will be very high near to the heat source, whereas at the other end the temperature of the metal bar will be very less. As we know that temperature always flow, that is heat always flows from higher temperature to lower temperature. So the temperature of the body increases from the metal bar, and as the distance increases the temperature of the body reduces. So the conduction always is a type of heat transfer and a mode of heat transfer that takes place from one part of the body to another part of the body, which are in physical contact with each other. And one of the important criteria is that both the bodies should not be in motion. So without appreciable displacement of particles of the body is an important criteria for conduction to take place, and conduction happens only in solids. Now, now let us look into convection. So convection is another mode of heat transfer where heat is transferred from one point of a fluid to another point of a fluid. So when I say fluid, I can imagine either a gas or a liquid. Okay, so convection naturally happens because of density difference. The best example that we can take is heating of water or boiling of water. When you take water inside a vessel, the water will be at a uniform temperature. But when you start heating the vessel, what happens? The bottom layer of the water will get heated. It becomes lighter. So lighter water will be transferred to the upper layer, but the cold water, which is at a lower temperature and with high density, will get transferred to the bottom layer. And this process continues, and hence the boiling of the liquid takes place. So this is one of the best examples for convection. So convection happens only in liquids, and it is a result of density difference. Convection happens only in fluids. The fluid may be a liquid or a gas. So there are two types of convection. One is natural convection and another one is post convection. So when does natural convection happens? Imagine I'm taking a tumbler and filling water inside this tumbler. Okay, let us imagine I'm taking a tumbler and filling water inside this tumbler and keeping this tumbler in the open environment. What happens after some 10 minutes? The temperature of the hot water inside the tumbler will get reduced naturally without using any mechanical aid. So this is called as natural convection. On the other hand, let us imagine I'm using any mechanical aid like a spoon to stir the water so that the heat transfer takes place at a faster rate. Similarly, with industries, you can imagine using an agitator, using a pump in order to facilitate the heat transfer, then it is called as convection. Now, let us look into radiation. Radiation is the final mode of heat transfer from where the heat transfer takes place from one body to another body through space, that is mainly through electromagnetic waves. Here, it is important to understand that conduction and convection need a material medium for to transfer, whereas radiation can happen with or without a material medium. Examples of radiation include transfer of heat from the sun to the earth and the loss of heat from an unlagged steam pipe to the ambient air. So here, by unlagged, I mean that a pipe without any insulation. So these are the broad three modes of classifications of heat transfer, that is conduction, convection and radiation. Hope you understood the three modes of heat transfer in a well understandable manner. So let us see the rest of the unit 1 syllabus in the upcoming classes. Thank you.